Okay, so let's finish up the testing we were doing last time. Let's do one more test. I want to do a test of actually buying an item, doing the whole process of being able to scan and purchase an item. So for this, we're going to need our self-checkout. I'm going to name this something I can actually type during lecture. Change this to a veil. Oh my goodness. And I want to create an item, add it to the store as an item for sale, and then purchase that item using the keypad and make sure that it's in the cart. So there's a lot of moving pieces with this one, so I want to spoil it in lecture and show you, give you a better feel of how you're going to use all these classes. So for your homework, most of it, the functionality, you're creating the classes, getting the functionality, implementing the methods. I want to show you how to actually use those things because you will have to use them for your testing. So first, let's create an item. I'm just going to steal an item from up here. Test item, very creative, Jesse. With a price of $100. And then I want to add this to a store with a specific barcode. So I'm going to do checkout dot add item to store. This does not add an item to your cart. It always creates a lot of confusion. It's named differently this year, add item to store. It used to just be add item, which is adding it to the store or your cart. It's questionable. Add item to store is going to take a string as a barcode. I'm going to use 427 because I already have the number press buttons set up for 427 or 472. And then the item to be added with that barcode. So now what this should do, and with testing we're just concerned about what should happen, is this should add an item to the store, test item with barcode 472. So if somebody goes up to the machine and presses 472 enter, they should have one of this test item in their cart. They're purchasing one of these test items. I got to name this something better. What should we be buying? What should this be?
Cheese.
Cheese. I love it. We're buying some cheese. We'll buy some nice cheese, but not quite $100 cheese. So we'll get some nice, really old, aged, sharp cheddar for $12. So let's buy some cheese with item 472. So to simulate this, we want to hit our button press, our number press, 472. We can still check the display string, but we tested that in the other test. One thing, it's recommended but not required, is keeping your test focused to testing one specific thing. That way, when a test fails, at a glance, you know what went wrong, what piece of functionality went wrong. If your display string is broken and buying an item fails, it's harder to tell what went wrong. So we want to do number pressed 472. We're going to simulate an enter being pressed. And now at this point, if everything's working well with this checkout machine, with this self-checkout class, we should see that item. We should see some cheese in our cart. So if I do, so I'll create a variable because I want to do some testing on this. A list of item equals checkout.items in cart. So we can access the items in the cart. Make sure you're calling the method. Don't access your state variable directly because you'll have naming conflicts. It's not going to exist in Autolab with that particular name. You're going to get some errors in Autolab if you're doing that. Make sure you're accessing it through the method call. And the reason we do that, well, one of the reasons is that method call is part of the spec. It's part of the API. It's part of what you're supposed to build in your software engineering contract. If this is actual software you're being paid to build, you're being paid to build the functionality that's on that sheet. Here are the specs. Someone's going to pay you a nice salary to implement those features. If you're testing features that aren't in that spec, Things can go wrong. One, you're not getting paid to do that, so why are you testing and making sure that works? And two, if you're testing something that's not part of something somebody actually cares about, what happens when you change that implementation detail? Another dev down the road changes the name of that, which is perfectly legal because it's not something the customer cares about. We can change the way we implement it. Well, now that breaks all your tests. Test the way people are going to use your code, not the way you implemented your functionality. It's just generally good practice. So we're going to check the items in that cart. And I always want to do one thing first when I'm testing a list like this. Let me back up a little bit. We can't just use equal equal. Does this cart equal what I expect it to be, which was a list of size 1 that has cheese? We can't just use equal equal here because we have a list of items and each item contains a double. Remember, we can't use equal equal when we're testing these doubles. So we do have to get into these lists manually at this point. The first thing, when I have to do this, the very first thing I want to do is assert the size of this cart. Cart dot, is it just size? Cart dot size equal 1. I want to make sure this cart has the right number of elements in it. In this case, just one thing of cheese here. If that passes, then I can start asserting other things. I can assert cart.head.description and make sure that's cheese in my cart. If we don't have this check, we're going to get some errors here, because what if the self-checkout machine is an incorrect solution, it's not doing what it's supposed to do, and it happened to return the empty list? Well, now you have cart.head, you're accessing the head of an empty list. That's going to cause an error. That's going to give you one of them concerned faces in Autolab. Things aren't going to work the way you want them to. Assert that the size is what you expect, and if it has something in it, then start accessing it. You can never make assumptions about the returned values or any value that you don't control in your code. And we want to make sure we got the right price. And we know how to do that, right? Now for this, we always got to think about our meaningful value of epsilon. For our cases, for everything we're doing here, as long as we're at least within a penny, a tenth of a penny I'm putting here, that's good for my accuracy. If we're within a penny, I'm feeling good. We got the right price on there. Or sorry, not within a penny, but if we're within less than a penny, a tenth of a penny here, I'm feeling good. Beyond that, I don't really care, so I'm going to allow differences of a tenth of a penny. We could put another 0 in here, but we don't want to go too far because we don't want to get into those truncation errors and start having a truncation error fail our test. So we don't want to go too far, but a tenth of a penny, hundredth of a penny, if you really want to go out there, it's going to be perfectly fine. And we have a test for our whole checkout process. This is a solid test. If your code's passing this test, you're probably done with task 1. I forget there might be something small that you could possibly miss but still pass this test. Oh yeah, I guess quite a few edge cases. Adding multiple items to the cart, things like that. Adding cheese twice. What happens if I do this and add two blocks of cheese? Things like that. You want to test more things like that. But if you're passing this, you probably have all those. You have to write more testing to be sure, but you probably have all that. All right, how's everyone feeling about this? I see some stuff in chat I want to catch up on. You feeling all right? my brain's trying to parse this. Just curious, when calling a method in a class, can you have a parameter in it? For example, but yes, you can. Yes. And the next example I show will have that. And we have it right here. Checkout is an object. Number press takes an argument. Yeah. Oh, I'm behind. Just realized there. That wasn't even from this lecture. Man, what am I doing? I'm out of it. If it's Whole Foods, it would be $100. Yeah, truth. Enter, good question. So it will be that cheese. So when we create an item, it's kind of a nuance of the way the assignment's set up. The item, objects of type item are storing the description of an item. Or not the description, because I'm already using that term. But it's storing the details of a type of item in the store. So you can think of this as like a line on your receipt that's going to say, this person bought cheese for $12. It's not the actual physical object of a thing of cheese. So when we add these to the cart, we actually want the item itself, that object itself. So if we add 2 things of cheese into our cart, we want that same exact item by reference to be added twice into our cart. That is the way we have this set up, because that's just the details of an item. It's not the item itself. I know that's a little point of confusion. It's set up a little strange. We almost called this item details to make that more clear, but I don't know if that would be just more confusing in the end. If you assert checkout items in cart equals list of test item, that should work. No, because you have a double. You would be comparing doubles with equal equal. Rezi, I don't know if that's a question, if you're answering someone else. It sounds like an answer. But if it's a question, let me know. Answer, cool. All right, anybody else have anything? I'm going to navigate away from the homework code. So if you want help getting started on homework 2, now's your time to ask questions. And by the way, I plan to leak test cases. Paul and I both plan to leak test cases on every task throughout the semester. So when we get to task 2 next week, I'll leak some task 2 test cases as well. The whole point of learning testing is to show you the value of testing, not to just put you through the tedium of creating tests, because tests take a while, especially in homework 2. You might spend more time on the tests than on the code itself. If you understand the concepts especially, you spend more time on the tests than the code. So I want to help you out, give you some test cases so you can see the value in having test cases, so then you can, it'll be more bearable when you go through the tedium of creating your own test cases if you already understand the value of having them. If you have this test case and you're writing your code, it's easier to tell if your code works or not. You run the tests. If you get a green check mark, your code works. If you don't, it doesn't. Very simple to tell. You don't have to trace through every single line of code. Once you have an error, it's recommended you trace through your code. But to tell if you have an error or not, how do you know when you're done? Well, when the tests pass, you still might not be done, but it's a good indication that you're on the right track, at the very least. No takers on homework questions? Or is everyone still thinking about homework 1? Yes?
Sorry, by homework 1, do you mean like project?
Project, oh yeah. I'll use homework and project interchangeably. Yeah. They're homeworks, but they're pretty large, so we call them projects, but same thing. Good question. Slides magically appear when you refresh. No, they didn't. Oh boy. let's do it this way. No, that's not going to work. I'll get there. Did I name it wrong? Maybe I named it for the wrong one. No. Damn it. All right, bear with me for a second. Son of a bitch. Why didn't you update? File's there. All right, now really, anybody have any questions? When can we expect to see quiz grades? By next Friday, like Saturday-ish. So I hold my TAs to getting grading done within a week after something's due. But with quiz and interview grading, we have labs until 10 p.m. or 8 p.m. I think 8 p.m. 8 p.m. tonight. So they can't get it done, and they can't really get started until 8 p.m. tonight. That's when we have all the submissions in. So a week from 8 p.m., ideally, they'll have it done. After that point, you can start yelling at me and saying, where the hell are my grades? And I'll start lighting a fire under the TAs, make sure they get it done. Hopefully, we'll get it done quicker than that, but it's 403 students across all the sections, so it takes a while. Yes?
Will we get them back, like, red pen marked up, explaining, like, what we lost points for, or something like that?
So all of your paper submissions, good question. All of your, I didn't realize I didn't talk about this at all. All of your paper submissions are being scanned by the TAs and then uploaded to Autolab. So in Autolab, you'll have a PDF version of your submission, and then if you got full credit, they might just, in the application objective and learning objective, they might just say, great job, keep up the good work. If you got anything off, if you didn't get the AO, or especially if you didn't get the LO, they'll give some feedback on what you did wrong. And that way, when it's all in, yeah, these are my new slides. And then when it's all in Autolab, we don't have to worry about handing back your paper submissions. So you won't see your paper submissions again, but you have the scan of them. There we go. It was right when I wanted to take a breather, too. So the rest of the lecture, we're going to go through this program, and I'm going to do the same thing I did last time. I'll give you a few minutes to look at the code and work through it on your own. That's what I was trying to do. I'm like, I have to update the slides. Oh, but the next thing I'm going to do is have them just stare at this for a while. I'll update the slides where they're staring at them. But the program's in the slides. Oh, crap. So I was almost at a spot where I'm like, oh, I'll just throw up the code, but I couldn't. So that was my frustration right there. And the slides updated, if anybody's curious, I don't know if you are or not, but I saved the slides and then pushed right away, but the file took long enough to save that I pushed before the file fully saved and updated and was recognized. So I just went too quick uploading it. It's too fast for the computer. So when there's multiple items in the cart, the order does matter this time, so we won't call dot sorted. Don't call dot sorted on these items. Make sure they're in the right order. Because when you're scanning them, they'll show up on the customer's receipt. Like you're actually at the self-checkout machine. You'll scan your items, and they'll show up on your receipt in the order in which you scan them. That's what we're going for here. And your total, subtotal, tax, and total will update as you're scanning them. We want all the order of all that to matter. You get the AO based on the written part. So if your memory diagrams are just spot on, you're going to get the AO as well as the LO for the written part. The interview is only for learning objective explain, that part, only for the learning objective portion. And part of that, it's just harder to make those judgment calls on the interviews is the reason we do that. We don't have an AO on the interviews. Depending on how well your TA took notes, and there's just a lot of factors that go into that. So we just want the LO bar on the interviews. All right, who's ready for this one? Anybody have questions as they're going through it? Get your hands on this and come across something that we can just talk about. Yes.
So if you're using, in the second box, you're using this dot battles one.
Mm-hmm.
Given that battles one is a variable already described in, like what if you didn't use this in that case?
If we didn't use this right here and just did battles one, it'll still see the same variable right here. Because the battles one in party character is going to be in a different scope entirely, it'll be part of a different object, that it won't be in scope, it won't be able to see it. But in right here, so now in scope right now, we have this variable XP and this variable XP. So if we don't do this .xp right here, then we are going to get in trouble. This is where it's required. We have to say this .xp to specify which XP we're searching for. Because if we just do XP, we're getting the local variable. We're getting that parameter. So it's a case where this is required.
Thanks.
Yes?
The fifth line of the name method, you make a party.
Mm-hmm.
You have hero, and then you have new party character.
Yep.
The new party character is the party character object that
Mm-hmm.
doesn't have a name.
It doesn't have a name. That's kind of the new thing I'm throwing at you here. So this is mostly an example, just getting more experience with classes. But that's the new thing. Like this party character isn't going to have a variable on the stack. And the reason I do that is because we think of like this party character is hero. That's what it is. And we refer to it as that. I'm doing this to emphasize the point that hero is just a variable that I named that stores a reference to a party character on the heap. And we can even do that without having a variable directly. We just create a new object on the heap, and then we're going to give that reference to the party constructor. And we'll see in the memory diagram how that all pans out. Yeah.
So this dot xp plus equals xp adds the xp defined in win battle to the variable xp up top, or yeah.
Yep. So this .xp is this variable. So it'll take this plus xp, which is the local variable, the parameter, and then reassign it back to this .xp. So it's xp plus xp equals xp.
Okay.
Good question. Party character takes no input. That's correct. All right. Let's memory diagram this thing. And I'm hoping there's no typos this time. I'm feeling bad. I got 2 days in a row with typos, which are updated. The slides are updated, but let's try to get this in the first shot. So we start the program. Always start at the main method. This is where our code executes. And this main method is technically in an object, which I forget what it's named, but it's in the repo. But just to save space on the slide, I don't have object name, brace, and then a closing brace at the end. So we start at the beginning of the main method. I got my stack and heap and in-out all set up. Got my memory diagram ready to go. First 2 lines, we should be pros at this now. Nobody should be having trouble just putting a few variables on the stack. I hope. Variable name, value, name, value. Since these are ints, we have ints, doubles, strings, longs, booleans, chars, byte. I feel like I'm missing one, float. Those will go on the stack directly. The value is just straight up the value. That's it. Everything else is going to go on the heap, and we're going to store references on the stack. These are ints, so we just throw their values right on the stack. Next line, we have a constructor call. We're going to call the party character constructor. This class we defined, its constructor takes no parameters, so we have no state variables being defined in the constructor itself, but we will have a couple set up here. So when we call that constructor, we put a stack frame on the stack. We put the variable we're returning to on the stack, show an arrow that's going to return. This stack frame, whatever the stack frame returns, is going to return into that variable named hero. Inside the stack frame, we have this, which stores a reference to the object that's being constructed. And on the heap, we're going to create that variable, that object that's not that variable, that object that's being constructed. So we asked the operating system, we said, hey, I need some space for a party character. It's going to need space for 2 ints. We get enough space for 2 ints. We're going to create the stack frame for the constructor, call that method, and then do what we're going to initialize on that object. We run all of the code that's outside of the methods, and any variables that are declared outside of the methods become state variables and are part of that object. Yes?
Can you explain where you got this from?
Magically. It just magically appeared. So this is one of the things that's kind of confusing about learning classes for the first time, that it is an implicit constructor parameter. So, any methods in an object, in a class, that we're calling, actually objects as well. Whenever we call a method or the constructor, there's an implicit parameter that we don't draw in our classes at all, but there is an implicit parameter of the keyword this, which is always going to store a reference to the relevant object. So here, for a constructor call, this is going to be a reference to the object that's being constructed. And I know that's confusing. It's one of them things that takes a while to get used to when you're learning objects in classes. It just comes out of nowhere, seemingly. I kind of like the way Python does it. It makes it explicit with the parameter self in all of the methods. But in languages like Scala, Java, C++, pretty much any other language, it's just an implicit parameter that seemingly comes out of nowhere. It's frustrating, it's confusing, but that is the way this works. So this, a reference to the object that's being created, and then any variables declared outside of the methods become part of that object. So we do have ints when they're state variables of an object. We actually do have 2 ints here that are stored on the heap. So ints aren't always stored on the heap, but if they're on their own, if the variables are declared on their own and not part of a state, not a state variable, then they're going to go on the heap, or on the stack. When they're state variables, that's the only time you'll see those on the heap. Constructor returns. We've seen a few constructor calls by now. Constructor returns, stack frame's gone. That stack frame is actually deleted off the stack, And the next thing I put on the stack will actually be in the memory location where that stack frame was. But when we're doing these memory diagrams, we're never erasing anything. We want a full trace. When this thing is done, we want a full trace through the whole program. So we're going to visually leave it on the stack, but the next thing is going to reuse that stack frame. Constructors return a reference to the object that was created. So this constructor is going to return a reference to the object that was created, whatever was in this, and that's what's stored in Hero. Hero does not store an entire object. It stores a reference, which is the memory address of where you can find that object on the heap. Yeah.
Oh, can you explain what new does?
New is going to call the constructor. Whenever we call a constructor, we use the keyword new. So new is saying, hey, I want a constructor call instead of a regular method call. Sound good? So when I say new party character, I'm saying create a new object of this type party character, give me a new thing on the heap, call the constructor, and then give me a reference to the new thing that was created. In short, anytime you see new, we're putting new objects on the heap. So we see 3 keywords new. By the time I'm done with this memory diagram, I better have 3 things on that heap. No more, no less. Yeah.
Oh, why is the heap value stored to this? Like the name this?
Why is the key value?
Why is, yeah, the 0x282, why is that?
Because that's the reference of where my object is. The actual value of that I just made up. I just made up a number.
Yeah, but I mean,
But that's wherever this object is being created, that's a reference to that. That's the reference that's going to be returned.
and when we go through class to do that, it's stored to the name this.
Why is it stored to the name this?
Yeah.
That's just the way Scala is set up. So this is a keyword. Like you can't name a variable this because it's a reserved special keyword that's reserved for this purpose specifically. So the Scala developers decided that variable that stores the reference to the object, we're going to call that this, and then nobody else can use the word this anywhere. So we don't have naming conflicts. It's just what they decided to call their variable. Yes?
So, are you able to, so when you're creating a constructor, do we always have to store that into the constructor into a variable?
Yeah. Wait. You mean like returning to the hero variable? Yeah. No, we don't always have to do that, and we're not going to do it right here. Right? Is that your question? Yeah, so when we get here, this behaves a little bit differently, and we're going to see how this one works. All right, our next line, hero.winBattle of mob XP. This, we haven't seen too many examples of this. Hopefully it's starting to become a little familiar, but this I expect to be pretty fuzzy still. In the previous line also. Hero.winBattle of mob XP. We got quite a bit of stuff to look up here. So hero is a reference. Hero stores the reference 282. And we're going to use the dot operator, which says, hey, hero, I know you store a reference. I don't care about your reference. I care about what you refer to. The dot operator says, take me to the object to which you refer. So hero dot means hero, this reference, follow the arrow to what you refer to, and access this player character. So I'm in a player character object, and I'm calling win battle. We have 2 methods called win battle in this program. Since I'm accessing win battle from an object of type player character, this win battle call is going to be the player character behavior, the player character win battle, not the party win battle. So we're going to party character, accessing the behavior of a party character object, so we get the party character win battle. That's going to take XP as a parameter, and whenever we have a method call through an object on the heap, we also get a reference to that calling object in this. So this is a reference to the object that called it, called this method. The object that called it, the object that we access the dot the dot operator from was the variable hero, which stores a reference 282. So in this stack frame, this is 282, the calling object. Bless you. We also have xp, the parameter, just like our method calls from LO1. xp of mob xp is 20, so xp is 20 in this stack frame. And we go through the code. This, again, using the dot operator, same thing that we just did with hero dot. This dot is saying follow the reference. So we're over here in this player character object. This dot battles 1 plus equals 1. So increment battles 1 by 1. We're going to cross out the 0 and write a 1. We followed the reference, found the object, incremented battles 1. This dot xp plus equals xp. This is what we were talking about a little earlier. We have two variables named xp, so our scoping rules apply here. If we just say xp, scoping rules apply. Look in the stack frame. We're not inside a code block right now, so we're not worrying about code blocks and dotted lines. But we're inside the stack frame. Search for a variable named xp. We found one, xp, value equals 20. So this dot is going to say this dot xp and access this variable here. If we just said xp plus equals xp, we're actually going to get errors. It wouldn't work because we're accessing this xp, and parameters are always vals. In Scala, we can't overwrite a val, so we'd get can't modify a val error. So we say this dot. In this case, this dot is required. We have to have this to override our scoping rules and say, no, I don't want the parameter xp. I want this dot xp. Follow this reference. Head over to the heap, access xp, and increment it by the value of xp, which I'm not overriding any scoping rules. xp right here on the stack, 20. So xp equals 0 plus 20. We get 20. Anyone have questions on this? This is a lot of what we need to talk about. Just these two lines, if you understand everything about these two lines, you're doing awesome. If you don't, I want your questions. How do we access the reference here? So I will get to that. Well, actually, will I? Yeah. I will get to it, but the very TLDR of how we access this is right here. Party dot character 2, that's the parameter where this went. Access character 2, and then access its XP. This will print out the XP of this character. Even though we don't have direct access to it, we do have indirect access by following a couple of references. Yeah?
Probably character 2 TWO there, but in the character 2 with the number.
I was hoping I wouldn't have a typo. I got one. That should be 2, the number 2. Okay. Hopefully it stays at 1. How did I miss that one, though? Because it has to be right in the repo. Or in the repo, I might have left it TWO. And then I shortened it just for the slides because it was overflowing. When I have the party box in the heap, it was overflowing that box. I think I just changed that on the slides, didn't I? Damn it. Thank you for pointing that out. I'll fix the slides. Getting sick of saying that. It's embarrassing. So the stack frame ends, removed from the stack. There's no return value. This doesn't return anywhere, and it has return type unit, so I don't have to worry about where it's returning to. There's no arrow for the return value. it's just done. So that stack frame's over, all these values are gone, and it didn't return anything, but it did make a change on the heap. So this is what we call side effects. This method changed the state of the heap. Player character is different. Hero still refers to this player character. So that method call did modify the object referred to by the variable hero. That change was made on the heap. All right, let's get to this big line. We got a lot of moving parts on this line. We're going to call the party constructor and have it return into a variable named party. That much we've seen. We just saw that in the party character class, that constructor. But we're going to create a new party class that's going to invoke the constructor. That's a stack frame. We have the implicit this, a reference to the party that's being created. We have character 1, which is hero, which is 282. Okay, that's good. We're feeling good. But party takes a second parameter, character 2. And we don't quite know what that is yet. And this is perfectly legal, by the way. We can nest method calls. We can nest constructor calls. We can do this till our heart's content. But we don't know what this value is. It's not on our stack. It's nowhere here. So before we can call this constructor of party, before we can really construct this, we need to know what this third parameter is. So we're going to have to add another frame to the stack to be able to create this, to go through this constructor, the party character constructor. So we're going to add another frame to the stack that's going to create another party character. We're going to get a new party character on the heap. I'm going to call it 496. That's where I'm going to put it in RAM. It's going to get battles 1 in XP just like Hero did. Just like Hero did in the party characters constructor outside of all the methods. And it's going to return to the character 2 parameter. It's going to return right to a parameter in another stack frame. This is all perfectly legal. It's not returning to a variable that's directly on the top level of the stack or in the main stack frame. It's going to return right to a parameter of another stack frame, of another method call, which in this case happens to be a constructor method call. So we're going to return that reference. This stack frame ends, returns the reference to character 2, the parameter. We're right in this constructor. Where the green arrow is where we're executing. So now we have all three parameters, the implicit this, the explicit character 1, and the explicit character 2. We got all our values, and now we're ready to run the constructor. So now we create the party object. It has character 1 and character 2. Those become state variables because they're in the constructor. All constructor parameters become state variables in Scala, asterisk in Scala. So we're going to put those parameters on the heap as part of that party object. Yeah.
Does the position of like the heaps matter?
Maybe. That's a good question. I'll always draw them in order, but if you didn't have them in that order on the quiz, would I care? I don't think so. Yeah, I'll give a kind of vague no to that. It doesn't really have meaning. Technically, when it's stored in memory, I think they would be in this order, but yeah, I wouldn't really care. But I'll be consistent in class. I'll put them in the order of the parameters and then the order in which they're declared after the constructor as well. Then we run all the code outside of the methods. Battles 1, variable declared outside of all the methods, so that becomes another state variable. We get another state variable here. And then that returns. Destroy the stack frame. Return the object that was created, a reference to the object that was created. Oh, and I missed my arrow. Dang it. That should have an arrow pointing to party. And then we have that on the stack stored in that party variable. All right, any questions on all of that? That was really the heaviest line that we have to go through. Yeah.
The characters would probably show up in a heap first and then the party, or like they would show up like that.
Mm-hmm.
The first, like the actual numbers of the registers, though, like this middle party character has the highest number.
Mm-hmm.
But that's not relevant.
No, and I mix them up. I do that on purpose to show you that it doesn't matter how they were called. It's when you ask for heap space, the JVM and the OS, they can give you any memory address ever. It'll depend on however they're programmed to decide what's the next memory address that should be given for your program. That can be anywhere. And the idea of references is we don't care where that is. We're just going to get a reference that gives us instructions to tell us where to go. And we just don't actually care where physically that is located. All right, now we have another win battle call. But this time it's party.winBattle. Party dot goes to an object of type party. So now we're calling the win battle in the party class. We're not getting the win battle in the player character class. So when we go to the party class, we have a different call. First thing we're going to do is this.battles1, this.battles1 increment. And then we have a more interesting scenario here. This.character1.winBattle. So inside this stack frame, we're going to say this. Every time we see the dot, it means we're following a reference to its object. This dot, we're over in this object. Character1 dot, character1 dot, follow the reference. And then character1, this party character, dot win battle. So we're calling win battle from this object. So this is going to be a reference to this object when we call win battle that first time. So we're going through the dot operators and finding the right object that's being referred to. Increment battles 1 and XP. And then do the same thing for character 2. Character 2, this.character2, this.character2, dot win battle. Increment, change the stack, destroy the stack frame, and everything returns. We finally get to the end of the program where we finally get to the end of the stack frame where we're printing to the screen. We're going to print hero.xp. Hero.xp is 120. And then party.character2.xp, which is 100. So we'll follow those references. And we're over by a minute, so no lecture question today. And I'll have a great week. I'll see everyone Monday. You can come down and ask if you got a question.